Hi everyone. Today we will begin lesson 3.1, Understanding Rational Exponents and Radicals. We will take a look at how to convert between radical and rational exponents. And let's take a look at the first explore activity. Um, As you can see that 3 to the third power equals 27. And if we continue the pattern, 3 squared equals 9, 3 to the first power equals 3. And then if we go backwards, we would reduce the power from 3 to 2 to 1. And if you keep going, uh, it will go to 0 to negative 1 and negative 2. And if you keep dividing in the same sense, 27 divided by 3, you will get 9 divided by 3, you will have 3. And then 3 divided by 3 is 1. And if we continue, 1 divided by 3 is 1/3. And then if we divide 1/3 by 3 again, we will have 1/9. And if you take a look, you actually would see that the pattern here is 1 over 3 to the first power and 1 over 3 to the second power. So in essence, you will see that the negative powers will turn into positive by dividing 1 over it. So that's the pattern. And this yields two properties. One is that the any number raised to the 0 power is 1. So anything that you can think of raised to the 0 power will give you 1. But 0 to the 0 is undefined, so there is no such thing. So therefore, the exception is x cannot equal to 0. And the same thing goes for the negative power. So anything negative, you will rewrite it as 1 over the power. And that's how you can get the positive power. And again, in the discussion question, it will ask you, why does there need to be an exception in the second rule? So why does x cannot equal to 0 here? Because if you let x equal to 0, you will end up with 1 divided by 0. And that's going to give you an undefined answer. So it is not possible to divide anything by 0. So this is why we need to restrict the denominator to not 0. So that's why we have x cannot equal to 0 as a restriction. Let's take a look at how the format of writing a rational exponent as radical. So the radical symbol, anything that has this root symbol is considered a radical form. So radical form has the radical root, just like here, and the components are made of this number outside. When there's nothing, by the way, it means 2. That's a square root. So usually when you write this, it means square root when there's no number outside. So this is the index. So for example, if this number is a 3, that would be, the index would be 3. That's a cube root. And then the number inside is called the radicand. So that's the radicand. And those are the components. And here's another format. You will rewriting it. This is the radical form that we were looking at earlier. So we have the index, and then we have radicand, and then the exponent. So if we were to write this as an exponent form, so this is exponent form. This is the exponent form. The exponent would stay on top, and then the index would be on the bottom. So usually I ask the students to remember that what's on top stays on top. So the radical has a power here is a, the exponent is a, it will stay on top in the rational form. So what's on top stays on top. So that's how you know the index is going to go on the bottom. Okay, so that is a little bit on the exponent and the radical form. So let's take a look at example 1. Simplifying numerical expressions with nth root. So if we take a look at the example, 64 to the 1/3 power. So the direction says find the root and simplify the expression. So if you look at the power, it's 1/3. So that's how we know that the radical is actually equal to the cube root of 64 to the 1 power. So that's 64. And if we rewrite the number 64 as 4 to the third, because 4 times 4 times 4 is 64, we can cancel out the cube root and the power. So they actually undo each other. And so we are left with 4 as the final answer. Another way we can look at this is you can continue using the rational form and rewrite 4 as a 64 as 4 to the third power. That will give us 64, right? And then raise it to the 1/3 power. And then since this is a power of a power, we can cross cancel the 1/3 and the 3, and we will have 4 as an answer as well. So it's the same answer, two different ways. Depends on what you prefer to work with, the rational form, the radical form, or the rational form. And let's take a look at number 2, the second one. 84 to the 1/4 power plus 9 to the 1/2. So we know that 84 to the 1/4. So using the radical form, you can rewrite it as the fourth root of 81. And then the 9 to the 1/2 power is actually the square root of 9. So we can rewrite the 81 as 3 to the 4th power. And so 3 to the 4th and then square root of 9 gives us 3. The 4 and the square root of 4 cancels each other out. So we have 3 plus 3, which gives us a nice and clean answer of 6. Again, if you prefer to work with the exponent form, the rational form, this is can be written as 3 to the 4th power, and then the 9 can be written as a 3 squared, and then we can work with the powers, cancel out the 4 and 1/4 and 1/2, and we're still left with 3 plus 3, which gives us 6. So either way, whichever method you prefer is fine. And let's take a look at these problems right here. Now these are your turn problems, so you need to pause the video and try the problems before you look at the answers. So go ahead and pause the video and try. Okay, hopefully you've had a chance to try the problem. Let's take a look at the problem. 8 to the 1/3. So we know that if you want to use the cube root, so that will be the cube root of 8. And you can rewrite the cube root, the 8 as a 2 to the 3rd power, and the cube root and the cube cancels out, and we have 2. And that will be the answer. Number 4, we can start by taking square root of 16 because 1/2 power is 16, and then the cube root of 27. And square root of 16 is equal to 4. And so then if you want to write the 27 as 3 to the 3rd power, we can cancel out the 3 and the cube root. So that will leave us 4 plus 3, which is equal to a nice and round answer of 7. And that's the end of that problem. Here's some more triad problems, so go ahead and try it before you look at the answers. Write the name of the property that is demonstrated by each equation. So this is actually applying the power to each member of the expression inside. So this is actually the power of the products because it's a product of two numbers inside. So this would be the power of product rule that you use to apply here. And then here, when we have the two powers multiplying together, it's a power of a power. So this is the power of power property. And those are the answers for the properties. And there you go, the answers again. Let's take a look at the next 3 problems. So we want to simplify 8 to the 2/3. So once again, if we want to convert this into the root radical form, that will be the cube root because what's on top stays on top. So that means this is a cube root of 8 squared. Now this square here, you can apply it either to the inside or the outside. So for right now, I'm going to leave it outside because it makes the problem smaller. So we are going to take the cube root of 8, and you can rewrite the cube root of 8 as 2 to the 3rd and still have the 2 power. The cube and the cube root cancels each other out, so we have 2 squared, which gives us the answer of 4. And make sure you try number 6 before you look at the answer. Again, this is going to be a square root because the number on the bottom is the root. So this is a square root of 25 and then cube that. So we know that the square root of 25 is actually 5. and then cubing that gives us 5 times 5 times 5, which is an answer of 125. Let's take a look at number 9 here. And the next one here is fourth root of 81 plus square root of 4. Now the square root of fourth root of 81, we can rewrite the 81 as 3 to the fourth power. Remember that? 3 to the fourth equals 81. And then the square root of 4 is actually 2. So the fourth and fourth root cancels out. So we have 3 plus 2, which gives us an answer of 5. So the answers are 4, 125, and 5. And here they are again. Next, more triad problems. So you guys can go ahead and try these problems before we do it together. Okay, hopefully you had a chance to try the problems. Let's take a look at number 4. Anything 1 to the any power is 1. You should have learned that property sometime in your classes in math. But 1 to the any power equals 1. So the answer is 1 here. Number 5, 9 to the 1/2 power. So that's actually, we worked with the root, the radical form for a little bit. So I will show you how to work with the exponent, the rational form, if you prefer to work. So you're comfortable with both methods. So we can rewrite 9 as 3 squared. I personally prefer this method right here because it's like nice and clean, only powers, right? You don't have any roots to deal with. So half of 2, we're going to apply the power of power rule. Half of 2 is 1, so we have the answer is 3 to the 1 power, which is just 3. Number 7, again, we're going to start with, so sometimes the problem is easier to work with radical, sometimes it's rational, the power, whichever one you prefer with is fine. So I'm going to rewrite 16 as 2 to the 4th power, and then I have still the power of 5 4th outside. And notice that when we multiply, applying the power of a power, the 4 and the 4 will cancel out, and we are left with 2 to the 5th power, which gives us 32 as an answer here. Next, working with 27 to the 1/3 power, we can rewrite the 27 as 3 to the 1/3, 3 to the 3rd, and we still have a 1/3 power. Applying the power of power property, we will have 1/3 of 3, which is 1, and so that will give us the plain answer of 3. And number 10, same thing, 343, we can rewrite it as 7 to the 3rd power, and then we have a 2/3 power outside, and 32 can be written as 2 to the 5th power, and then 2/5. So sometimes you do need to know the basics of what powers do you get when you multiply certain power. It helps you to simplify easier. So the 3's will cancel out, so we have 7 squared, times the 5's will cancel out, we have 2 squared, which is 4. So we got 7 squared, which is 49, times 4, that will give us an answer of 196. And the last problem here in this section, notice we have a negative power. So the first thing we're going to do is apply the negative power property and write a 1 over the 1/2 power. And that will be a positive 1/2 now. So now, next, we're going to rewrite the 100 as 10 squared, and we still have the 1/2 power. And applying the power of power function, the rule, we have 1 over 10 to the 1st power, which is just 1/10. Or you can write the answer as 0.1 if you prefer, but 1/10 is just perfectly fine. And here are the answers again for the problems that we just did. And that's the end of the lesson for today. So go ahead and get started with your homework by logging into Google Classroom and check out your assignments. See you next time.